Hello everyone, this is Dr. Sunita M, working as an associate professor in Marri Reddy Institute of Technology and Management. In the previous classes, we have gone through the problems based on a finite automata, that is regular expressions, deterministic finite automata, and in the previous class itself, regular expressions we have seen. So in the today's class, we'll see the conversion of our regular expressions to the finite automata. Okay, let us see how this conversion of a regular expressions will be going to proceed. So first let us see what is a regular expression first. Okay, a regular expression is a simple and effective way to describe pattern in a text, okay, such as any number of a's written as a star. Okay, a star indicates what? In the previous class itself, I have said star indicates that zero or more number of occurrence. Okay, star indicates. So here A star means what? It may be 0 or 1A or 2 A's or 3 A's, n number of A's, either A or B. So written as how? A or B. So a finite automata is a basic machine that reads a string one character at a time, right? Finite automata, and decides whether it matches a given pattern or not. Okay, so here first few words about a regular expression. That is, a regular expression is a simple and effective way to describe pattern in a text, such as any number of A's written as A star. So A star indicates what? 0 or more occurrence of a, either or B. So written as what? A or B. A finite automata is a basic machine that reads a string one character at a time and decides whether it is matches a given pattern or not. So converting a regular expression into finite automata means transferring the pattern into a machine that can automatically check if a string follows that pattern or not. Okay, so this process is very useful in a computer science and practical applications. It allows computers to automatically recognize and process text patterns. It is used in tools like text editors and search features to find matching strings. Okay, it plays an important role in programming languages and compilers, especially in a lexical analysis. Okay, as the regular expressions can be constructed from a finite automata using a state elimination method or a subset method or a reverse method or state decomposition method, which can be used to construct a finite automata from the given regular expressions. Okay, so note here is that this method will construct NFA with or without epsilon transitions depending on the expressions for the given regular expressions, which can be further converted to DFA using NFA to DFA conversions. Okay, so state decomposition method. This theorem, every language defined by a regular expression is also defined by a finite automata. So proof is that, let's assume L is equal to L of R for a regular expression R. We prove that L is equal to L of M for some epsilon NFA. Okay, with, okay, how we are going to prove that? Exactly one accepting state. Okay, exactly one accepting state, no incoming edges at the initial state, no outgoing edges at the accepting state. So what are initial state and what are accepting states here? Initial state is nothing but what? A start state. Accepting state is nothing but what? A final state. Okay, right? So what they said is exactly one accepting state, that is only one final state should be there, and no incoming edges at the initial state. Okay, and no outgoing edges at the accepting state. This states state decomposition method. Okay, now let us solve few problems on conversion of a regular expressions to a finite automata. Okay, so design a finite automata from the given regular expression 1 0 plus 0 plus 1 1 0 star 1. Okay, just we need to design a finite automata for this regular expression. Okay, let us start. Step 1. What is step 1? First, as it is, we need to draw. Okay, so first will be our initial state and the other one will be the accepting states. That is Q naught. I'll take it as a Q naught initial state, and QF I'll take it as a accepting state or a final state. So transition is 1 0 plus 0 plus 1 1 0 star 1. Okay, so here see Q naught is a start state and QF is a final state. Okay, and step 2, so just we need to go on splitting this expression, that is Q naught. Okay, Q naught, as here plus sign is there, what does that indicates? Pluses or. If dot is there, multiplication sign is there, means we should use it as AND. As it is here a plus, so what we will do? Okay, this is final state. So once it can go with only 1 0 to the final state, or 0 plus 1 1 0 star 1. Okay, either directly with input 1 0 it will reach to the final state, or 0 plus 1 1 0 star 1 it will reach to the final state. So step 2. So next is step 3. We can split this 1 0 Q naught Q1, this will take it as 1, QF, this will take it as 0. This, can I keep this as it is first? Or else Q1. Okay, first Q2 will take. See here, as here it is a dot, we can split this also. So this I'll write it as 0 plus 1 1 to Q2, and from Q2 to QF is 0 star 1. Okay, see here, this 1 0 I have taken it as split into Q naught, Q1, QF. With input 1 and 0 it is reaching to QF. But see here, 0 plus 1 1 0 star 1 is there, that I have taken it as one more state, a new state I have taken, where 0 plus 1 1 is here, Q naught to Q2, and Q2 to QF I have taken it as 0 star 1. Okay, next step, we can split this into, okay, here I'll draw. Q naught, Q1, QF, this is 1, this is 0. Okay, but here see, Q2 is there, already Q2 is there, so 0 plus 1 1 is there. Okay, 0 plus 1 1 is Q2. As here 0 star is there, 0 star indicates what? 0, because 0 or more occurrence of 0 input symbol here. Then 1, it is reaching to the final state. So 0 star 1 we have simplified now. Next we should simplify this. That is, we can split that, right? Q naught, Q1, this is QF, this is 1, this is 0. Okay, 0 plus 1 1. So 0, one more set, already Q2 we have taken here, Q3 I'll take a new state. Okay, this is 0. Okay, Q2 already is there, so this I'll take it as Q2. With 1, 1, it is reaching to Q3. So Q3 I'll take it as here 0. Or else, if you're getting confusing, you can name it as here Q2. This you can name it as Q3. Okay, Q3, because already we have taken it as Q2 as a 0 star, and this will reach to the final state, that is 1. Okay, this is how we need to represent a finite automata from the given regular expression. Okay, see, once again I'll explain. So this is the regular expression they have given us to find the finite automata for this. Okay, first, in a simple, just take 2 states and put this expression Q0, QF. Next, go on splitting. So plus indicates what? Or. Okay, dot indicates what? AND operation. So here 1 and 0 dot is there. So 1 0 it is reaching to QF, and 0 plus 1 1 0 star 1. So that we have taken as a one more transition, which reaches from Q0 to QF. So it is reaching to QF with the 2 input symbols. That is, one is 1 0 and the other one is this option. Okay, again we need to split this. So 1 dot 0. Immediately after 1, 0 is there. So Q0 1 0. Next 0 plus 1 1 0 star 1 is there. Okay, so 0 plus 1 1 we have taken here, and one more state we have taken Q2. From Q2 0 star 1, because this is here dot. Next step 4, we have split this 0 star also. So 0 star indicates what? A loop. See here, a loop we have taken, which is a 0 there and 1. So Q0, Q1 0, QF, and from Q0, Q2 0 we have taken. Next 1 1 we need to represent. So one more new state I have taken, which I am representing with 1 and 1. Okay, and which is ending with input symbol 1 to QF state. So this is how we need to represent a given expression into a finite automata. Okay, let us see one more example. Okay, design a finite automata from the given regular expression. 1 1 star 0 1 star 0 1 star whole star. Okay, first what we should do initially, first step, what we'll take a Q0, QF. How we are going to represent this? 1 1 star 0 1 star 0 1 star whole star. Okay, next how we are going to split this? 1 is there, as this is a whole star is there. So Q0, QF, this is 1, and this, as because it is a whole star, I'll take like this: 1 star 0 1 star 0 1 star. No need to represent here again star, because already I have taken a loop here. So remove that star. Okay, now 1 is there, this is there. We need to split this now. How? See, Q0, QF, this is 1, right? Okay, and 1 star is there. I'll represent that with 1 here. Loop indicates what? 0 or more occurrence of that input symbol. So it may be either 0 occurrence or 1 1 2 1 3 1, n number of ones. Next is what? 0. So shall I take this as a one more state to represent? Q0 already I have taken. So next I'll take it as Q1. So already this 1 star is done. 1 star 0 0 Next, one more star is there. One star, because loop I have taken, so that indicates what? 1 0. This one. Next, again, one star is there. This one star will be again repeated this. This is how we need to represent the given regular expression into a finite automata. Okay, so it's the first only with the two states we have represented. Then next we are going to split those expression. If we require a more number of states, we should use, or else no need. As star indicates what? Loop. So we can take a loop here. Okay, and 0 1 star 0 1 star. So whole complete expression is represented now. Okay, so this is how we need to solve the regular expression into a finite automata. Okay, these are some references, textbooks we need to refer. Thank you.